So on a problem over there, if I asked you that just to see who's paying attention when you're reading the test, if I did on a test say, what's the velocity of the object, you would write unknown, because I didn't tell you. I have another beam being held up by two wires. Tension in one wire is 80 newtons, the tension on the other wire is 40 newtons. The weight of the beam is 50 newtons. I have an unknown weight acting on it as well, as shown in the diagram. What is the weight of the unknown object? Or how would you solve it?
Could it be negative?
Possibly, depends on how you're solving it.
You would add those three?
No.
No.
Well, depends on how you add them.
And then,
You're adding vectors.
I don't know.
I would combine 80 and 40, and then subtract 50,
Yeah.
and that goes next.
So I have 120 newtons acting up. Therefore, what is the total force that must be acting down if it's in equilibrium? I think somebody just said it.
120.
So if I got 120 up, I gotta have 120 down. I know 50 of it comes from the weight of the beam. Therefore, that has to be whatever the difference is between 120 and 50, or 70 newtons. If that 70 newtons is caused by an object hanging on it, what is the mass of the object? Should bring back some fond memories from the lab that you did last Thursday. How do you find the mass of an object if you know the weight?
I don't know off the top of my head, it sounds about 9798, something like that.
What do you do with that number?
You multiply it by that.
By the 70?
Yeah. Multiply 70 with the 9798 number, I think it's 9798, something like that.
All right, you see the ballpark. Not quite there yet.
Do you add all of that and then multiply it by that?
No, you need to get to the 70, but you're not going to end up multiplying.
Would it be 70 equals n times 9.798?
Sorry.
70
you said-
equals n times 9.
Oh, M. Sorry, I heard
Like-
10. Just so you know, on February 10th, I'm going to get my hearing aids, so I'll probably be able to hear this. I'm hoping. Somebody in the other class said, we'll just talk talking more softly. Please don't. The formula, W equals mg. That's the formula we're working with here. Now, in the first part of the lab, you had the mass and you multiply it times little g here to get the weight. Now, I'm giving you the weight and asking you to find the mass. So we have 70 is equal to mass times the acceleration due to gravity. In other words, if I take this object and I drop it, it is the rate at which its velocity changes. The acceleration of the object in Winston-Salem, 9.798 meters per second squared. Technically, newtons, since I'm putting units in one place, I'll put them in the other. The math problem we're working with is just 70 is equal to 9.798 m. That is the math problem. M stands for mass, not meters here. So given this, how would I solve for mass?
Divide the 9798 by 70.
I thought that's what you said.
I said my 70, but,
Oh, you went the other way.
yeah.
I heard the 7. Filled in the rest. You want M all by itself, so you have to get rid of that stuff that's tacked onto it. So whatever 70 divided by 9.798 is. Now, in a lab, yes, probably you're gonna be using 9.798 for most of it, for most of the labs. In the textbook, I think he uses 10, he just rounds off to 10 a lot, or 9.8. So just be aware, if you're looking at the homework problems and he divides by 10, there's a good chance he's just rounding off. And so what do we get?
7.14. 7.14.
And then units?
Newtons. No. Math.
Meters per second?
Not grams.
Say it again?
Is it grams?
Not grams, but you're a lot closer. You're in the ballpark.
Kilograms?
Kilograms. But wait a second over here. If that's 70 newtons divided by 9.789 meters per second squared, how do we get from newtons over meters per second squared into kilograms? It's because the definition of a newton. A newton is what's referred to as a derived unit. 1 newton equals, by definition, if you ever see the 3 lines there, that means it's true because the powers that be have defined it that way. 1 newton, by definition, is 1 kilogram times meter per second squared. That is a 1 there. If we go back to that equation that we had written on the board, F equals ma. If that's true, the unit should work out. Well, the international standard unit for force is a newton. For mass, it is a kilogram. And for acceleration, it's a meter per second squared. A newton is the same as a kilogram meter per second squared. So when it divided by meters per second squared, I'm left with kilograms. I think at that point, we've covered everything that we need to for chapter 2. So, what we're gonna do here, is come over to the handy dandy wall chart. It's the 21st. Let's see, we're just Tuesday, Thursday. So 23rd, 28th. All right, so a week from today. We're gonna do the homework quiz on chapter 2. For the homework quiz, if you go on the Blackboard, there should be textbook homework problems. Excuse me. The textbook homework problems and giving you a certain number from ranking. Let's see, for chapter 2, they have ranking. Is this the old version? Oh, this might be the older version. There's think and rank, think and suddenly blanking on the different categories. There's different categories of problems. Think and rank, think and explain, plug and chug, think and discuss, and think and rank. Did I did that? All right. What was the other one?
What just says plug and chug, think and solve, think and rank, think and explain, think and discuss?
Solve was the one I left off. All right. So there's 5 types. Chapter 2, I don't think has all 5 types, but I have a certain number of problems that are listed under textbook homework problems that are eligible for the quiz. I'm gonna take one problem of each type. So if there are only 3 different types for chapter 2, it's gonna be 3 problems. If there's 4, then I'll do 4 problems. If some chapters, there'll be 5, and there'll be 5 problems. I'm gonna take one of the problems of each type that have been assigned. If there are any numbers, I'm gonna change the numbers. I'm gonna then present that to you as an in-class quiz. The first one is usually not an issue, but I will put a time limit of a half hour on it. First one is usually the fastest. So, any questions on that?
And where do you find that?
Under, did I start this up again? I did, okay. Blackboard, under module 1 probably, chapter 2. You scroll down, there should be.
Forces in motion.
Pardon?
Forces in motion.
That's the module.
Okay, yes.
Then you should see chapter 2.
For some reason it says content isn't available for module 1, but 2, 3, and 4, let's
Oh.
go and do it.
Oh. Yeah.
I found it on module 2.
Yours is on module 2, for momentum and energy.
No, it shouldn't be.
Module 2 is on
You're not seeing for module 1?
It doesn't
No,
let
it
you,
says it's available.
it's not available.
Okay. Well, it will become available. If I do not have that available to you by 4 o'clock this afternoon, somebody send me a nasty email. Preferably, I'm not gonna get 20-something nasty emails, but, one will do, saying, hey, dude, you said you were gonna have this available by now.
And the background and review isn't available.
Textbook homework work problems,
Yeah, something like that.
they're under supplemental materials.
Those would be the solutions.
Oh,
I should have it set up so that under the textbook, under the module chapter, those would have just the problems without the solutions, and then you go to supplemental to see the solutions. Because some people are too tempted if they're all together.
Okay.
And strongly recommend, don't try to memorize your way through this course. Please don't. It's gonna be torture for you. Try to understand the problems. I think I've answered the question, other than the fact that it's not available yet. And if you went to the solutions, you would see the problems there too, but. All right, I'm gonna do start on chapter 3, do about 14 minutes of it, and then we're gonna break because there are 3 groups that still have not finished the lab from last Thursday. And so I'm gonna give them an opportunity to finish it. If you have finished it, then you are not a prisoner, you are free to go, or whatever you need to, but we will at least start on chapter 3.